Let's continue our regression analysis. So we're going to remove the finished basement because it's the higher of the two. Once again, you're probably thinking, oh, well, let's just remove them both. But once again, as we've seen, the significance has been getting better. So once I remove the finished basement, the question is, will the loft then become significant? We don't want to go overboard, so move or copy. Create a copy all the way here at the end. And left click there to drag it over because it didn't go where I wanted. Let's rename that, and that's going to be minus finished basement. Okay, so we're going to remove that column of finished basement and rerun our regression analysis. So data analysis, regression, and have the dependent variable hasn't changed. The independent one has. It's no longer running from B to G. It's only B to F. So I'm just going to come in here and change that to F. And also going to move the output range from I2 to H2 to drop it in the same place. And okay. Yes, rewrite it. It redoes it. Now let's take a look at things. So now that we've removed the finished basement, we can see that the loft and den is above 0.05. It's actually gotten worse because it was at 0.17. Now it's at 0.22. So without a doubt, definitely the finished basement, the loft and the den should not be part of the analysis. So let's move or copy, create a copy. Drag that to the end, rename minus loft. So again, I'm doing this to make sure that as we're looking at it, we know what's going on. And then I'm going to remove the loft den. Should work at this point because everything else is already significant. And so we've reduced it down to just a lake view, bedroom, bathroom, and acreage. But let's find out. Data, analysis, regression. We need to reduce this even further because we're no longer B to F, we are B to E. And then I will put it at G to drop it in the same spot. I'm going to hit OK. I'm going to overwrite the data. And now we're in a point where if we look at all of our p-values, those are significant. We have no issues with the significance of any of that data. So we're going to keep everything in the model. So we look at our R squared. R squared is 84.1, so 84.1% of the variation can be explained by our variables. So 81% of the variation is based on lake view, bathrooms, bedrooms, and acreage. And so here are our coefficients for our regression equation. They are all significant. Once again, I'm ignoring the p-value for intercept because there is going to be nothing going on there. So let's write our regression equation for predicting the house prices. So the asking price in thousands of dollars is going to be 82.755 plus 156.69 times the Lakeview. That's a dummy variable, 10, plus 29.227 times bedrooms, plus 29.23 times bathrooms, plus 44.8 times acres. So there's our regression equation where Lakeview is a 1 or a 0, whether it has a Lakeview or not. Bathrooms are the number of bathrooms, bedrooms are the number of bedrooms, and acreage is just the number of acres. So let's look at the interpretations. The intercept, the 82.755. we've got really no solid data that comes out of that. That really doesn't mean that much. So let's look at Lakeview. So basically, if the house has a Lakeview, the asking price is roughly $157,000 higher than an identical house with no Lakeview. Because it's a 1-0 variable, so it's either has it or doesn't have it. All the rest of them, the bathrooms, the bedrooms, and the acreage, if the house has one additional bathroom / bedroom / acre, the estimated asking price is, let's say, goes up by 29.2K for, 29.2K for the extra bathroom. It goes up by 25.9K for an extra bedroom, and it goes up by 44.8K for an extra acre. And so there we go. Now we can predict what the price of a house would be using this regression equation. And more importantly, the regression equation tells us factors about the house. So there we go. And that is how we would use it, how we'd filter through the data. If you have any questions, please let me know. Otherwise, I will see you in the next video.